Okay, ji. Kinematics, lecture number 2. So we started off with kinematics from the very basics, displacement, speed, velocity, average velocity. Then we worked upon acceleration, equation of motions, uniform acceleration, deceleration, and then uniform, non-uniform acceleration and deceleration concept. Working on kinematics, that is lecture number 2. Now, let's just work upon the graph itself. Let's say we have a graph, creating a graph. Now, I'm starting off with distance time graph, where here in the y-axis we'll have distance and we will have time in the x-axis, right? Let's say we are starting off with 0, t1, t2, t3, t4, t1, t2, t3, t4. Let's create a graph as well. This will be increasing speed when we have a curve. Then we'll have uniform speed. We'll have uniform speed. Then we'll have decreasing speed. Right? Let me just draw the graph properly from the point. We'll be having decreasing speed, and this will show me the constant. That means the distance is covered at rest. So there are pointers that you need to understand here. That means this point here graph is showing from 0 to T1 is increasing speed, or we can say it is accelerating body. In this part, T1 to T2, uniform speed. Uniform speed where acceleration is equal to 0. This is decreasing speed where acceleration is equal to acceleration will be there, but it will be decreasing acceleration. So this is decreasing deceleration. Similarly, at this point, the speed is equal to 0, or we can say at rest. At rest. Now, what are the pointers that you need to understand? Distance covered can never be negative. Never be negative. 1. Number 2, gradient of a distance time graph represents speed. Gradient represents speed, which means change in x and change in normally your s and t. So distance time graph represents what? Speed. That means gradient represents your speed. Moving further, then what do we have? Let's say we need to cover down displacement time graph. Displacement time graph. So again, drawing the straight line, right? Let's say this becomes your x-axis. Since we are making displacement time graph, your y-axis will show me displacement and your x-axis will show me time. I'm just holding on to writing time for you to understand something. Your normal, let's just work down with same T1, T2, T3, T4, T5, T6, right? Now, displacement, what does it show? Let's say in the initial phase, it will tell me the increasing velocity from 0 to T1. And increasing velocity is always shown in the curve part. This is your increasing velocity. Acceleration in this is in the positive direction because it is starting. Then uniform velocity will be from T1 to T2. Let's just say this becomes your uniform velocity. Acceleration is 0. This is positive. Then we'll have decreasing velocity. We'll have decreasing velocity. From T3 to T4, velocity is 0 but at rest. Here's the interesting part. Here's the interesting part. Let's say T4 to T5. Increasing velocity, but in the negative direction. That means increasing velocity in the negative, coming back in the negative direction. Then we have is a uniform velocity, but negative. Here, I'll introduce T7. Straight line, introducing T7. And this will tell me that T6 to T7 is decreasing velocity, deceleration is in the negative. The curve will be from down. That means this particular point here You need to understand it is your increasing. This becomes uniform velocity positive, decreasing velocity positive. This is at rest, increasing in negative, uniform in negative, and decreasing in negative. And we are at the rest now. We are at the rest now. Okay. Moving further after T7. Now you need to understand, let's say that we have T8. We'll work down with T9, T10, T11, T12, T13. And this is representing what? Time. So, what do we understand here? Now, since we are working with displacement time graph, we are working with the mean position as well. That what is exactly the mean position? The start. That means now this thing is covered. That means, for suppose, if I say from 0, right, there is a object that is going, that is T1, right? The body is moving till T2, the body is moving till 3, the body moved, right? But then there was a rest, there was a rest. And then again, the body moved in the direction. So this was T5, then T6, and at T7, it is at the mean position. It is at the mean position. That means it came along where it came at the initial point of time. Now, what you need to understand is that even though mean position is there, right? The mean position will be there. Now, again, there is a rest. Again, there is a rest. But now, the body, this point will show me that there is a rest, right? This point is telling me that there is a rest. And now this body is again moving, but now it is moving in the increasing velocity, but in the negative. So that means acceleration is in negative direction. So increasing velocity, but in the negative direction. So that means it is like this, right? So this is your negative direction T9. So here, if I just draw the same thing, this will go towards the left because T8 is here. So this becomes T9. Now, similarly, we can have from T9 to T10 uniform velocity. This shows me the uniform velocity, straight line. That means still this thing is moving towards 10. But from 10, let's say the body has got rest again. So if it is rested, so it's a straight line. It's a straight line. And then 11 to 12, increasing velocity. Increasing velocity. And in the end, let's say decreasing velocity directly without any constant speed. Right? So this means T10 means T11. This will be T11. This will be 12, and then at t13 will be at the mean position, will be at the mean position. So this actually is showing me this actually is showing me what? Displacement time graph. This actually is showing me what? Displacement time graph of the body. So let's just work out with each of the following. T0 to T1. This is increasing velocity. This is increasing velocity, right? Acceleration in positive direction. Acceleration in positive direction. This will be uniform velocity. Acceleration is equal to 0. This will be decreasing velocity. Decreasing velocity. Deceleration in positive direction. This thing here is, that means velocity is equal to 0 at rest. T4 to T5 is increasing. T4 to T5 is basically increasing velocity. Increasing velocity. Acceleration in negative direction. In negative direction. Uniform velocity. Uniform velocity. So, since this is uniform velocity, but acceleration is 0. And then, lastly, T6 to T7, decreasing velocity. Decreasing velocity. And in negative direction. In negative direction. Now, this point is velocity is equal to 0 at rest mean position. This is your mean position. Then what do we have? T8 to T9, increasing velocity. Increasing velocity. Negative acceleration in negative direction. This thing represents T9 to T10 uniform velocity. Uniform velocity. Right? So acceleration is 0, but in negative direction. This means at velocity 0 at rest. But again, T11 to T increasing velocity. Increasing velocity, but acceleration in positive direction. Again, going towards the mean position. This is decreasing velocity. This is decreasing velocity per deceleration is in positive direction, going towards the mean. T4 to T5, it is in increasing velocity. Acceleration in the negative direction, coming back towards the mean position. Because obviously from rest, from velocity, it was here 0. We rested. So obviously the speed will be increased. So increase in velocity, but obviously acceleration will be there to go towards the mean position at this point. So it will be in the negative direction. Here positive direction, here negative direction. Negative direction and negative direction and positive direction. So this is your displacement time graph. Okay, ji. So let's just work upon speed time graph now. So the y-axis represents speed and the x-axis represents time. So the same concept T1, T2, T3, T4, T5, T6, T7, initial phase requirements. So let's say from 0 to 1, we have increasing acceleration. Increasing with the curve, we will have increasing acceleration. T2, we will have uniform acceleration. T2 to T3, we'll have decreasing acceleration. T3 to T4, we'll have acceleration 0, that means uniform speed. Then T4 to T5, deceleration, increasing deceleration. Then T5 to T6, uniform deceleration. And then decreasing deceleration. Decreasing deceleration to come at the point at rest. So let's say T7 to T8, we are at rest, but we'll go further down. If we just say T9 and T10, let's say we have rest, and then we have after rest, we have a straight line. This tells me what? T8 to T9, this is uniform acceleration, and T9 to T10, we can have these uniform deceleration. So what do we have? Let's just work out with each thing for the speed time graph. So the first thing what we have is increasing acceleration, non-uniform acceleration. Similarly, this will be uniform acceleration. Then we have is decreasing deceleration, non-uniform acceleration. decreasing, I'll just correct, acceleration. And non-uniform acceleration. Here, acceleration is 0. Uniform speed. This will be uniform speed. Then we have is decreasing deceleration. Or we can have non-uniform acceleration. Non-uniform acceleration. Here we can have is from T5 to T6 uniform deceleration. Uniform deceleration. Now, lastly, what do we have is T6 to C7, T6 to T7 is decreasing deceleration. Non-uniform acceleration. This is at rest. This is uniform acceleration. And this is uniform deceleration. So this was your normal speed time graph with the uniform acceleration and uniform deceleration as well. So what do we have here in this? There are a few pointers that you need to understand as well. Number one, M represents, that means gradient represents acceleration here. Number two, area under the speed time graph represents total distance covered. So there are two things that you need to understand. Third thing, when we have straight line, we can find out equation of speed and time using y is equal to mx plus c when speed is given and to find time or vice versa. So this is your speed time graph. Okay, the velocity time graph. So in the y-axis we have velocity and the x-axis we have time. So we'll be starting off with T1, T2 again, 0, T1, T2, T3, T4, T5, T6, T7. So let's just mark the pointers. So what do we have here is increasing acceleration in the positive direction, uniform acceleration in the positive direction, decreasing acceleration in the positive direction, and this shape uniform velocity acceleration is equal to 0. Then this will give me what? Increasing T4 to T5, increasing deceleration in positive direction, uniform, and decreasing T6 to T7, decreasing deceleration in positive direction. At this, we'll be reaching to the mean position, and the mean position is exactly same. T7 will be represented by here, this point of displacement. Similarly, then what do we have is, let's say T8, then let's just work down with T8, T9, T10, T11, T12, T13, T14, and T15. Right? Let's just mark the pointers as well to be sure. T8, T9, T10, T11, 11 to 12. This will be your normal form. So if we just go through the same pointers, so this is at rest, T8 to T7 to T8. Object is at rest, increasing acceleration in the negative direction. So increasing acceleration in the negative direction. Then what do we have is T9 to T increasing acceleration. T9 to T10 will be uniform acceleration. And then we will have decreasing acceleration in the negative direction. This is your T11 to T12 uniform acceleration will be 0. Similarly, from T12 to T13, we'll have increasing deceleration. Then we'll have what? Uniform deceleration in negative direction. And then we'll have this. So what do we have? Decreasing deceleration, and so this will be represented by the velocity time graph. So again, increasing acceleration, positive direction till the end, right? Then all the thing will be positive direction, positive direction, positive direction. Acceleration is equal to 0. Then we have positive direction, positive direction, positive direction. Then we have are at rest. Then what do we have is negative direction, negative direction, negative direction. Obviously, we'll be working down with acceleration is equal to what? 0. And here we have negative direction, and negative direction. These will be uniform speed when uniform. Obviously, T3 and T4 will be what? T3 and T4 will be uniform. Velocity acceleration is equal to 0. Uniform velocity acceleration is equal to what? 0. T7 to 8 object will be at rest at positive displacement. Positive displacement. Similarly, uniform deceleration from T11 to T12, uniform negative velocity, negative, and obviously the acceleration will be 0. So already you know this is increasing acceleration, this is uniform acceleration, this is decreasing acceleration, then this is increasing deceleration, right? These all things will be depending upon acceleration. then this thing and this thing. Whereas your negative deceleration, this will give me my negative deceleration as well, but this will be increasing, but this will be decreasing. So similar contact to the part B. So let's just say this is A and B. This is A and B. So you need to understand that area of A plus area of B will be the total distance covered. Area of A plus area of B will be total distance covered. So this is pointer. The other point will be area of A minus area of B. This both will be equal to the final displacement of object. Final displacement of the object. So area of A plus area of B will be total distance covered, whereas area of A minus area of B will be the final displacement of the object. So this was lecture number 2, comprising of distance time graph, displacement time graph, speed time graph, and velocity time graph.